Welcome to this brief tutorial of the AudioAnalysis software. This is a quite simple program that can in real time display various types of spectral features of sound. In the main part of this program, you will be able to see a spectrogram running from right to left, where you can see features of the sound. And here, while I'm talking, you will be able to see this pass through. Then that will show you the continuous audio signal over time, and the immediate analysis result you will see here in the spectrum here on the right here. You will see that when you have peaks coming here on this part here, they will also show up in the spectrogram when they run over time. Otherwise, the software is quite simple. You have most of the tools available here in the top part. You can start and stop the processing of the audio with this button. You can choose whether you want to present the spectrum in grayscale or in color, depending on what you prefer. You may change between showing the amplitude and the phase of the signal, and I guess the amplitude will be most interesting for most people. There is the possibility to change between a linear and a logarithmic view, and that's quite useful in a musical context where it might be more meaningful to show the logarithmic view rather than the linear view, so you can see more of the relationship between the different harmonics in the spectrum. So if I whistle, for example, they will perhaps be more easily recognizable using the logarithmic rather than the linear display. I can try also to whistle here. And also if you have more overtones, you will be able to see them perhaps more easily with logarithmic view. It's possible to go here on the range and adjust that to see how much of the amplitude that you will actually display. It can be useful to set the range a little bit higher. You can click and drag here, and then you will actually filter out also some of the background noise here, as you will see here, or if I change to logarithmic. That will also then remove most of the other noise components. You can also change this down a bit here on the right side to show all the parts of the spectrum. Or you can go back to show the whole range again. You can also change the frequencies or the range of the frequencies that you want to show. Right now we have 100 Hz at the bottom and we have 10,000 Hz at the top. You can change this to anything you like. For example, if you want to look at frequencies between 50 and 1000, I just type in the values here now, and then I will get those instead here in the display. Obviously, and then this is a fairly narrow range, so you will mainly see most of the content in the lower part of the spectrum, at least of the voice. You can also, if you want to look at the full spectrum, you can typically go up to 20,000 Hz. That's close to the sampling frequency that we are using here, and then you will see the entire spectrum. For various types of voice analysis and music analysis, you might consider having something between 100 and 5,000 or 10,000 Hz, depending on what you're looking at. At the bottom here, you can change between which sound cards you're using, and also whether you're using the built-in microphone or some other type of microphone to read in audio to the program. If we click on the More Analysis button here, we'll get up a new window where we get various types of perceptual relevant features being plotted. So while the spectrogram and the spectrum show you various types of what you can say qualitative information or visualization of the sound, in this window we will get various types of quantitative information. To the left we see the continuously evolving bark spectrum, which is a specific type of perceptually relevant spectrum, as well as the loudness, noisiness, and brightness features of the sound. These are also then plotted over time here, so we can see a pitch estimator at the top, where you can. So if I whistle, you will see that it tries to estimate the pitch that I'm whistling. You will see the brightness of the sound, which is calculated from the spectral centroid. You will see what is called the noisiness of the sound, which is calculated from the spectral flatness. And you can see the loudness, which is calculated by the spectral energy. Also to the right here, you see visual representation of the pitch estimation, and there's also a small onset detector that will try to estimate the onsets and also tell you the beats per minute of either if you're playing or if you're talking. Finally, if you click on the README button here, you will get a little bit more information about the different features, and well, that's more or less it.